Mark Russinovich, I'm Chief Technology Officer of Azure.
Wonderful. And I'm Marshall Kirkpatrick. Thanks so much for joining us, Mark.
Thanks for having me.
Mark, can you share with us some of your favorite stories and examples of roadblocks that businesses and other organizations have faced with regard to security, privacy, and implementing AI? What have been some sticky problems that organizations needed to solve?
Well, that's a broad question. So in the context of confidential computing and how it addresses those concerns that are relevant for that, it actually goes back to even enterprise workloads. As customers, when I started in Azure in 2010, were concerned with putting their sensitive high IP data in the public cloud or their customers' data in the public cloud. And the public cloud has matured a lot, obviously, in the last 20 years in terms of providing security controls and privacy controls to safeguard that data and operational controls to safeguard that data. And that has allowed this massive migration and usage of public cloud. That said, there are still enterprises that I talk to, especially in regulated industries, in industries that are, for example, financial, which is very sensitive, in healthcare, where there's still data sets that they're not comfortable putting in the public cloud even now. And that number that fortunately continues to shrink. But my vision from 2014, when I first heard and kind of learned about trusted computing, was that confidential computing could actually provide this extra layer of protection that might make it viable for them to move their workloads in the public cloud. And so when we now fast forward to AI and what customers are doing with AI, one of the examples that I think resonates is customers that, just as one AI example, speech transcription, where they're saying their speech that they're collecting, that they record in their enterprise is extremely sensitive. In some cases, actually, if it leaked, it could have moved their markets or has IP in it that their competitors could take advantage of. They want that extra protection of that thing is going to be protected with confidential computing end to end. So just like messaging systems have end-to-end encryption, they want end-to-end generative AI, encrypted generative AI. And confidential computing offers that promise. Unlike the messaging services where you just have decryption and encryption on each side, with something like AI or the speech transcription, you need to actually process that data in a cloud environment. Take advantage of the power of the GPUs and the cloud services. And so that's where they want confidential computing to create this black box around that data while it's being protected. So we see a lot of customers really excited about that use case, as well as the multi-party cases where they can bring their data together and perform computations on that in an external environment like a public cloud and take advantage of that scale.
Can you share an example or two of the multi-party processing that you find especially exciting?
There's one that I think represents the future of advertising. It's with one of our customers, RBC, Royal Bank of Canada. And they've been looking at confidential computing for 4 or 5 years now. And when they approached us, they said, we see confidential computing as being able to really address this risk that we carry or can't even carry of targeted advertising for our loyalty customers. They're a credit card issuer for consumers. And one of the things that they see in their credit card statements is consumer bought X amount of product in dollars or Canadian dollars at this store, but they have no idea what's in there. Only the merchant knows exactly what they bought. And what they want to do is have that connection between what they see, which is consumers using their credit cards at multiple merchants, and what exactly they purchased at each merchant that would give them the insight to say when a consumer goes into a store, for example, hey, it looks like they're about to go on another trip because they just bought an airline ticket. They bought one last year. They wanted a trip. When they went to the store before the trip last year, they bought these items. It looks like they're about to shop for those kinds of things again. By knowing that, I can actually give them offers that are very targeted and relevant for them. And with confidential computing, they can actually merge the merchant data and the credit card transactions together to get that long-term view of the consumer that is obviously extremely sensitive, right? Very privacy and invasive if it's just out in the open, where if it leaked, you'd know exactly what this person's doing and buying everywhere. So with confidential computing, they're creating this clean room where they can merge that data together, and then RBC can't see the merchant data, the merchants can't see the RBC data. The consumer, of course, just gets very targeted ads, but knows that their privacy has been deeply protected. I think this really represents the future of advertising.
So confidential computing makes a greater degree of granularity possible between multiple parties.
Yeah, they end up not trusting each other. They trust the code and the hardware that's protecting that code.
Amazing. So in all of your years working in this space, what are some of your favorite success stories, and what does success look like? What kinds of business benefits have you seen organizations enjoy after an implementation?
I think the business benefits are exactly what I just said, that extra degree of assurance. And I think confidential computing has different values, propositions, depending on how you look at it. In Microsoft's own case, we're looking at it as defense in depth. We want to add this extra layer of protection around our most sensitive data, which starts with things like how we sign code, the systems that sign code, because that is basically, everybody trusts the code signed by Microsoft. Obviously extremely risky if that's exposed. Another one is the signing of our identity tokens. Lots of business systems trust a token issued by Microsoft Entra as our identity service. If somebody compromised those keys and could sign arbitrary tokens, they could get access to any customer's data. And so we are looking at it as, let's put those things in confidential computing and get this very high degree of protection that wasn't possible before. And so that's one case for us, just as defense in depth. And a lot of customers are looking at it as keep myself and my employees and whoever else might get into my infrastructure away from this data. And then the other one is the examples that I've talked about around multi-party computation and the value that you get out of that. Because, for example, being able to get a healthcare insight out of merging x-rays with patient diagnosis, with clinical trials, and then being able to get on a model that can very accurately predict some particular ailment, where you couldn't do it just based on one of those data sets. But multiple parties, those data sets are owned by different parties, and they're not comfortable, or regulation today might prevent them from sharing that with each other. The value that this unlocks of being able to say, no, I'm not going to share my data with you, and then who knows what you're going to do with it. I'm going to share it with this code that I trust, and this hardware that I trust to protect that code and the data. And that's going to unlock this value that was just not accessible, not available to me before.
So healthcare providers could, for example, put medical records into larger contexts and perform new analyses of them that they can't right now without confidential computing, and have greater efficacy. And
that's right. And the same thing applies to, for example, fraud, human trafficking. We see those cases too from financial services, where the fraud is something that regulators want to come in and understand, know your customer, anti-machine, money laundering. How can we do that without exposing the very sensitive data that those transactions represent? We don't want to know these banks and these consumers, these corporate entities were performing these kinds of transactions. That's very sensitive and, again, potentially market moving data. If we can do that kind of fraud, that analytics in a confidential computing boundary, the regulator can get reports out that shows these algorithms run on this data. Here are the findings. And only those findings that are risky are made available to them. Nothing else is. And again, multiple financial providers can bring their data together to get this very rich insight into follow the money.
Those are really good qualitative, newly enabled use cases. But do you have any quantitative business impacts that any of these organizations that you're working with have experienced that you can share?
I don't have any dollar values because, and some of these are just, we're like I just talked about in the keynote, we're at a breakout point for confidential computing. This has been for Microsoft a 10-year journey of building the software, building the understanding of it, getting the hardware into our data centers, pushing the hardware ecosystem into making confidential computing hardware as powerful and friction-free as general purpose computing. And we're right there. Like this year and the next year, that's the year. Like the software's there, the systems are there, the hardware is now coming. So what I've talked about are some of the early explorations of this and early adopters, and Microsoft itself is an early adopter of it. But what you're going to see in the next couple of years, I think, especially with generative AI and some of those examples that I mentioned there, is an explosion. Like the moment of confidential computing is here.
So, given that unique point that we're in history, are you shifting your strategy as a technology leader to meet this new era? How are things changing strategically for you?
Yeah, well, actually, interesting you asked that, because now that we've got these basic building blocks in place, now that we've got this line of sight to we can put confidential computing in every single server can support confidential computing that we deploy going forward. Today, up to date, we've just had to deploy specialized clusters of confidential computing because it can't run general purpose computing. Now that we're at that point, we're ready to say, how do we re-architect Azure and Microsoft on confidential computing? In fact, that's what I'm working on right now.
Can you tell us a little bit more about that? That's great. What are you thinking? What is it looking like?
So what we're thinking is we're actually taking a look at the core of Azure's platform, the most sensitive services, the ones that are at the foundation, the trusted computing base of Azure, and saying, let's get those into confidential containers. And so that, it's a massive effort. It's going to take years, but we're embarking on that journey.
That's great. So that will shift the entire industry and multiple industries. Where do you see the confidential computing field in general going, and where would you emphasize? Where would you like to see it go?
Yeah. Well, one of the things I concluded the keynote with was a change in the way that we should need to look at confidential computing. Because if you take a look at the way people have looked at it up to now, and it's just been because of the limitations in the hardware and the software services that go with it, we viewed it as a way to have full control over what touches my data. I have a SGX Enclave or a Intel or AMD confidential virtual machine. I put code in there. Maybe it's the ISV's code that goes in there with it, and that I allow it to access my data. That's a very IaaS-centric view of confidential computing. If you really want to take advantage of cloud scale and cloud services and all the richness of cloud, which if you're not taking advantage of, it's like I'm going to stay in the IaaS world and all my competitors are in the PaaS world and SaaS world, you need to let other code that is upgraded and managed by somebody else into what we're calling the confidential trust boundary, that data boundary that has access to my sensitive data. So the question is then, what can confidential computing do for me in that world where I've got my IaaS VM, but it's calling out to another service to perform some processing. That service is run by somebody else. They're upgrading it themselves. Is the answer for that me auditing their code, looking at the millions of lines, looking at every check-in? Do they have a backdoor? Do they have a vulnerability? Obviously, completely impractical, if not impossible. In fact, Reflections on Trusting Trust, a famous paper by Ken Thompson, shows that if the compiler's backdoored, you can't spot the backdoor. So really, what confidential computing ends up evolving to is, how can I guarantee that if I suspect that somebody's violated my trust, has leaked my data, and put a vulnerability that might have been exploited, how can I go and have the ability to audit and determine if that's the case? And so we talked about something called Code Transparency Service, where the code actually can only be deployed if it meets certain policy. And that policy includes the fundamentals that we believe. Like the code is escrowed, all the artifacts that went into creating the code are escrowed, and the code was built in a reproducible way. And reproducible means built in confidential computing with measurements and attestations. And if I have those two things and they meet other policies, then I can get this guarantee of, hey, I think last month you rolled an update that had a backdoor in it. I'm going to go pull the code. I'm going to go rebuild it and verify that it was indeed given the log, the audit log, the immutable ledger of what you deployed last month, verify that this code actually was the code that touched my data. And now I can take my time and inspect it with I think there's a backdoor here, and then find it. And if I find it, of course, then there's other implications. But that is not possible today. The ability to guarantee audit of code that is running and touching my data. And that's I think the strongest guarantee, and it's a very strong one, that we can make with confidential computing.
Wonderful. So instead of needing to trust everything, confidential computing will help point me towards specific places that I need to go and,
That's right.
and investigate. So, Mark, can you talk to me about what you envision the impact, whether it's on the economy or society, the world at large, the world of technology? What are the impacts that you're hoping for from confidential computing?
So there's two, I think, impacts. One of them is increased security, increased protection of data, and more trusting code and not people. The second is this multi-party scenario. So first, building systems that are all confidential will just increase this level of security. And if you have the transparency that I talked about, now we have supply chain provenance and tracing that's down to this actual piece of line of code, way downstream, touch this data on this date, which is a level of security that we haven't achieved before. And the whole world is relentlessly wanting to push in that direction. If you take a look at like software bill of materials executive order from the US government saying, we want to know exactly what we're consuming, confidential computing will give them a story about exactly what they're consuming, and that applies to any enterprise that's consuming software through a supply chain. But the other one is the multi-party scenario, which I think that one has huge potential to unlock value that's just sitting there latent because we're not able to share data with each other. But if we can share data with confidential computing, I mean, imagine the acceleration. If you combine the acceleration of AI with the acceleration of multi-party data sharing on top of that or underneath that, or financial or government, I mean, that is enormous amounts of value that confidential computing can unlock.